Alright, hello, my wonderful students. This is part 3 of Foldable number 2. For this one, we have our 8x squared plus 27. Oh, this is actually going to be equal 0. Forgot to write that down, sorry. So for this one, we actually have a difference of, or not a difference, this is a sum, because adding. This is actually going to be a sum of 2 cubes. So for this one, the sum of 2 cubes is when you have a cubed plus b cubed. This is equal to a plus b times a squared minus ab plus b squared. So first things first, we have to establish our a and our b. Oh, this is not squared, sorry, it's supposed to be cubed. Go. All right, so our a is going to be, well, I know from our cheat sheet from back in the day that 8 is actually equal to 2 cubed. So I'm going to write 2 and then x cubed, because 2 cubed is 8 and x cubed is x cubed, plus, and I remember that 27 is actually equal to 3 cubed. So it's going to be 3 cubed. So now we have our a is equal to 2x and our b is equal to 3. So we can, this is all equal to 0. So we can go ahead and rewrite this as this equation here. So we have our a, which is 2x, plus our b, 3, times our a 2x squared plus, minus ab 2x times 3 plus our b squared, 3 squared. Go ahead and simplify. We have 2x plus 3 in parentheses times our 2 squared is 4, x squared is x squared, minus 2 times 3 is 6, carried on the x, plus 9. Alright, for this one, we have both of these. This is still equal to 0 here as well. So first thing we can do is this one. We have 2x plus 3 is equal to 0. Subtract 3 to both sides. We get 2x is equal to negative 3. Divide by 2, divide by 2. X is equal to negative 3 over 2. Then we go ahead and go on to the next one over here, which is this one here. Yes. I noticed that these are all square roots, this one and this one. So I wonder if this is a perfect square trinomial. I believe it is. So in order to figure this out, we have to take this one here and find our a, which is going to be equal to, or it's going to be a squared, minus our 2ab plus our b squared. So we really just got to make sure this is equal if we do that. So we'll find our a. Our a is actually going to be 2x squared, and our b is going to be 3 squared. So this times this is going to be 6 times 2 is going to be 12. So it doesn't seem like it works out. And that means we're going to have to go ahead and use our quadratic formula. Since I use 3 colors here, I'm just going to do it in red. So if x is equal to negative 6 plus or minus the square root of negative 6 squared plus 4 times 9, which is our 4ac, all of this over 2 times a, which is 4. We're going to go ahead and simplify. We have x is equal to 6 plus or minus the square root of 36 it's supposed to be minus 4ac. I don't know why I put plus there. Minus let's do this. Let's see. 4 times 9 is 36. 36 times 4, 24, 2, 12, 14, 144. All over 8. 36 minus 144 is, well, 44 minus 36 is 8 with the 100. So this will be 6 plus or minus the square root of negative 108. Well, 108 is just 9 times 12. It's actually also 36 times 3, which is also a perfect square. So we can rewrite this as, over 8. We can rewrite this as, I should have wrote this here. Do it right here. Just notes for this as 6 plus or minus, if we change this to a side note in green, as 36 times 3. The 36 will come out as 6, so it would be I6 or 6i square root 3 all over 8. We can divide each of these by 2, so then we're getting 3 plus or minus 3i square root 3 over 4. These are 2 possible zeros plus our third one, so we ran out of room to write our zeros, so I'm just going to go ahead and just box all our zeros here, and these are going to be our zeros, 1, 2, 3.